Hi, I'm Bob with LPS Computer. Today I'm going to show you how to replace the carriage belt and do a paper advanced calibration on a Designjet 1050C Plus. The procedure is exactly the same if you do it on the 1055 CM Plus or the 1050 or 1055 CM. I'm going to use the instructions provided in a kit that comes from LPS Computer. It's illustrated instructions, several pages of step-by-step on how to do this. Kit also comes with a CD that has the manual on it, that has all these instructions in it, error codes, procedures, part numbers, so on. Of course, the kit has the belt. The belt is made out of Kevlar and high-density polyurethane. It's made on a mold that's owned by LPS Computer. The mold, the materials, the labor, everything's made right here in the United States. And in fact, only the LPS belts are the Designjet belts made in the United States. All the rest come from Asia, including HP. HP belts are made out of the same material, probably from DuPont. Kevlar, in fact, I know comes from DuPont. The Asian belts, so far as I know, all the other Asian belts are made out of neoprene and fiberglass. I know they're advertised, they say they're using Vectran and other things. And we've bought them, we've cut them apart, we've looked at them. They're fiberglass. They're yesterday's news, yesterday's technology. If you want a really good quality belt, very accurate, very smooth running, you got to buy an HP or an LPS. And the LPS belts cost less than the HP belt, so it's definitely the best value you're going to find for this kind of a repair. The kit also has comes with the tools that you'll need. It's got Torx bits and the handle. There's a socket wrench there. You need to get one of the nuts off. A couple of specialty tools that come with it. Everything you're going to need here for this repair and any future repairs is here. Kit has non-evaporating oil. This is kind of an important detail because you need the friction to stay the same left and right in the carriage motion. When the machine does a y-axis calibration, it measures the friction left and right, does a voltage offset for the motor to get those speeds exactly the same going both directions. If at some point the friction changes, then you start to see some zigzag in your output, and that's not a good thing. So you want something that's going to remain constant, and non-evaporating oil will. If you're using a spray-on oil, it will actually get sticky as it evaporates and work against you. So important little detail, nice thing to have. Also in the kit we have calibration media. This is a sheet of polyethylene film with a photo gloss finish on it. HP used to supply these sheets when they were available, but I think so far as I know, the sheets are no longer available anywhere. We buy this by the roll and have it cut for us just for the kits. So the main reason we like the film is because it's very stable thermally. It won't change size or shape because you've touched it with your hands. And it won't change shape or size from the moisture from the ink or atmospheric humidity. It's very stable stuff. So when you can print the pattern, you rotate it 90 degrees, put it back in, you're going to get the most accurate calibration possible. This is my cuss rag in case things don't go well. Hopefully we won't need this, but if I feel a cuss coming on and I want to throw something, this is a nice safe thing to do. So anyway, let's take this machine apart and put the belt in. I'll show you how to do that. Okay, the first thing we have to do is take off the front cover and the top cover of the machine. The front cover is a snap-on hinge, and it just pops off, just like that. We can let's go ahead and set this aside. Okay. There's 6 screws holding the top piece on. There's one in the front, this black screw right here. It's a T15. And I'm going to go ahead and take that out as soon as I find my screwdriver. There we are. And there's 5 more screws along the back. I'll turn the machine around so you can see them. There's these 5 screws right here. And I'm going to use my magic screwdriver that comes in the kit. Poof! This is a handy thing to have, but you may not want to let your kids play with it. For that matter, you may not want to let your wife know you have this either. Okay, this top part is also snapped on, and it just pops off just like that. And that's all there is to the top cover removal. Okay, well, I've got the back exposed here. I'm going to take off the 2 connector panels in the back to expose the connectors that are on the electronics module. I'm going to be taking off the right cover. It's on the left side right now, obviously, but the cover contains the control panel, which is connected with this ribbon cable right here. So we can disconnect that so we can get this off. There are 6 screws that hold the right and the left end covers on. There's a hidden screw on both sides. I'm going to show you where that is. I'm going to zoom in on this. There's a hole right here. The screw is missing, and it typically is missing after it's been taken apart one time. Technicians tend to leave them out because it just slows them down next time. So that one's out. That's screw number 1. Screw number 2 is right here. I'm going to go ahead and take that out. Stubborn. The rest of these screws are accessed from the front. And there's 4 screws here. There's 1, 2, 3, and number 4. So I'm going to go ahead and take all of those out. Okay, screws are out. This cover's almost ready to come off. You want to make sure that the cleaning station, the head cleaners, are not all the way out. So just push that back away because that'll interfere with this coming off. Now at this point we can just slip this cover right off. Carefully you don't snag the cables in the back. Now there's one more cable here. I do support this with my knee. And probably can't see this very well, but it's a simple connector to get apart. You pinch one end of it and it comes apart. And that's the right end cover removal. Next, we're going to take off the left end cover of the machine. For this, we need to take the ink supply station completely out of the printer. So that requires the removal of the ink itself. Okay, there are 6 screws just like the other side, the 4 in the front. The hidden screw down on the inside that's usually not put back in, and the one up in this corner. Now in addition to those screws, we have to open up the back door here, again using a T15. Many times these screws aren't in there because they've not been put back, and we'll let that hang. This is the part of the ink tube system. This is the part we need to remove. This is the actual ink supply portion of the ink tube system. This is a retaining clip, and we have to lift up on this. Sometimes they're a little stiff. Sometimes they're a lot stiff. Then there's 2 latches here. One goes left, one goes right. And we can move this out just a short way. Now there's two connectors here that need to be disconnected. One of them is the air supply. Push down the silver button and pull it loose. The other is this ribbon cable. Pinch it on both sides and it just comes off. We'll set those out of the way and pull the ink supply system completely out of the machine. We can set that here for now. Now we'll take all of the screws out of here on the front and the back. They're exactly the same location as they were on the cover's ready to come off. There is a little latch right here that is not obvious. All the screws are out, but it still seems solid. It's because it's latched right here. This can just be lifted up one and slips loose, and it comes off from there. Okay, next we're going to take this tube system completely out of the printer. First thing we need to do with that from here is to remove the print heads. Move the carriage to the left, and we'll get the print heads out of here. Now these will dry up over time, so it's a good idea to put these in a Ziploc bag with a damp paper towel. You could save yourself some pain later. There's a T8 screw in the top here, and we'll show that to you. Okay, the screw we're looking for is it's on the top of the machine, top of the carriage rather, and it attaches the ink boom to the carriage cover. And you'll break one or the other if you don't take this off before you try to take the tube system out. So it's a T8, just back that out and you're good to go. T8 is out. To open this up, there are pressure points, thumb latches, and you get a hold of that and you pull it free from the carriage. Put this down and move it out of the way, and this comes up between the frames, and that's pretty much it for getting the tube system out. This has a little latch on it. You pull on it or push on it or cuss at it, and it pops loose. Tube system's out of the machine. Next thing we're going to do is remove the trailing cable from the carriage. To do that, we're going to move the carriage all the way to the left. And I'm going to rotate the machine around here a little so you can see what I'm doing. This is the trailing cable where it plugs in. This pops off. Sometimes it cooperates and sometimes it doesn't. We'll just encourage it a little bit here. Now we can see the trailing cable connectors. There's a stiffener on the bottom of this, and it all goes through this thing here with some little tabs. If you take it off the tabs, it becomes much easier to pull these out. These are easily damaged. You want to come straight up with them. Inspect them for any kind of damage. These look good. I usually run this all the way out the end of the printer just to have it out of the way, and it gives it some protection. And that's all there is to removing the trailing cables. The encoder strip needs to be disconnected. This is the one end of the encoder strip. Push the carriage back into the machine a bit. Again, I'm using a socket wrench from the kit. This is a 7/39 or something like that, I don't know. Whichever one fits. I'm going to take this nut off. And the washer. This piece is actually a piece of spring steel. So to take this tension off of that, press in on the steel, and you can see it start to pop loose, and then you can just let this hang loose. This needs to be removed because there's a screw here we need to get out to take this assembly off, and that's what we're going to do next. We're going to take this tensioner assembly off, but to do that we need to get a little slack on the belt. This is the end of the motor pulley right here, and we're going to take the belt off the motor pulley just by lifting up on it and rotating it like that. And it's loose. I'll go back to this end. And we'll take out this screw and this screw. And we can remove that assembly from the printer. Now the pulley right here just pushes out, and it'll bring the belt with it. Something like that. This is the tensioner assembly. These parts plus the housing. Now the belt's free, and this will just slide off. Okay, this is the tensioner wedge, and as you can see, there are barbs on this and a mounting point for the spring. The reason for the barbs is they're actually latches that will hold the spring down in this assembly. You put the spring on the other anchor point, fit it into the assembly, and you can latch this down. There's a tab on it, and you can latch it down. It holds the spring compressed. And when we put this back into the machine, that's going to be very convenient because we won't be fighting the spring. We'll have slack in the belt. Just a tip. Okay, the carriage is ready to come out of the machine. It's a good idea to keep your hand toward the back of the machine because there's spring-loaded bushing there that will find some inconvenient place to hide if you don't capture it. So keep your hand back here, and as that pops loose, it'll just fall into your hand, just like that. I take it out because it still tends to go places when you don't want it to, kind of like that. And pull the belt out, and we're ready to disconnect the belt from the rest of the carriage. Okay, the belt goes through a channel in the bottom of the carriage, and it's held in place just by the teeth of the belt going through matching teeth in the channel. So we just need to pull that out of there, and it's free. And you set the carriage aside carefully. The belts that go on this printer have teeth on the same side. It has ribs. Ribs go toward the tensioner pulley, the teeth go toward the drive side, which is the motor pulley. Our belts differ from the OEM in that there's a splice at one transition. So when you're installing this belt, the teeth are still going to go toward the motor, but the splice goes toward the tensioner pulley. Doesn't really matter where it goes underneath the carriage, as long as it is in fact under the carriage. There's quite a bit of room there so that it doesn't hit the pulley. If it hits the pulley, it's going to generate a check paper path error. So better to favor the center of the carriage when you're installing this belt as far as the location of this clip. Okay, I've replaced the belt here, and you can see I put the belt through the channel, teeth to teeth, clip toward the idler side of the machine. The part of the belt with the teeth goes toward the motor. So I'm going to go ahead and put the spring and the bushing on the back and slide this back into the machine. I'm going to put a loop of the belt up between the rails just to kind of make sure it goes where I want it to go. Get this front bushing first. Compress the spring a little and get the rear bushing in. And we'll slide this right back into the machine a little bit. Or not. Okay, it's hanging up on a finger underneath the carriage is part of the clutch assembly that helps move paper when you're supposed to. I need to show this to you. And you depress that a little bit, and you should be able to see that right here. That's what was hanging up the carriage when I put it in. So you depress that, slide the carriage past that, and the carriage is back into the machine. Now there's a real important point I need to show you here, and that is with this encoder strip. The encoder strip has to go through the encoder sensor. A lot of times it tends to get behind it like that, and that doesn't work. That will generate a check paper path error. The carriage will jerk just a little bit, generates the error. If that happens, that's your problem. So you want to make sure it's inside the sensor, or that, not inside the sensor, but goes through the sensor when you put all of this back together. So we're going to put that in, slide it downstream a little bit, and the carriage is back in the machine. At this point, mostly it's the reverse of the steps that we went through to
Okay, now we're going to put the tensioner assembly back on so we can mount this belt. Okay, take the belt. Going to make sure it's not twisted in any way, and loop it through the two sides of the tensioner wedge. Slip the pulley in here and pull that into the slot right here, and that's all there is to that. We don't want to unclip it yet. Just remember we clip that up, and we'll get back to that in a little bit. Now on the other end, the motor side, we need to put the belt over the motor pulley. This motor pulley has a lot of debris in it, and that needs to be cleaned out before we put the belt on. A lot of older belts will disintegrate and load up the teeth in the pulley, and that's going to give you a very lumpy motion if you don't clean that out. So I'm going to clean that out before I put the motor, before I actually put this back together. But I am going to show you how to slip this over the motor pulley. Okay, to put the motor pulley, put the belt over the motor pulley, we're just going to start one edge and then roll it right over and it slips right on. I've rotated the plotter around so you can to the other end of the tensioner side so you can see the clipped tensioner again. I'm going to use a small blade screwdriver, flat blade screwdriver from the kit, and undo these clips. There you heard it click. That's where it came loose from the latches. And now this belt is tensioned. You want to let the spring do the tensioning. There's no adjustment beyond that for the belt tension. That is it. It's a calibrated spring. I'm going to put the encoder strip back together. So I'll need to put the spring steel back here. This is the encoder strip, the end. So I'm going to have to bend that in quite a bit and slip that over there, and that will stay put until we get this nut on. Okay, next thing I want to double check is to make sure that the encoder strip is still going through the center of the encoder sensor, and it is. So we'll just leave it right here, and we're going to be in this position to put the trailing cable back together, which is our next. Now we're going to reattach the trailing cables. And as I mentioned, these edges are very fragile, so be very careful putting them in. We're going to get them all nice and lined up, nice and vertical before we actually push them in. If an edge does get messed up, you can usually peel it back with your fingernail, and then it's much more critical getting it in, but it can be done and salvaged. So just take these very carefully one at a time. Okay, I believe they're all in. Now we can line it up with the stiffener here, and we want to make sure they're all matched up, coming all the way up to the carriage. Now we're just going to pop it into its keeper here, just like that. Okay, then the cover goes right back on the top there, and the cable is back.
Next thing we're going to do is a resistance check to make sure that the trailing cable is on correctly. If it's not on correctly, you can blow a fuse on the motherboard, F7. In this case, F7 is right there where we're looking. So what you want to read on your ohm meter is between 100 and 200 ohms, or maybe even a little higher. So I'm going to go in here with my, these are the two test points. These two right here. Since I'm holding a flashlight, it's kind of hard for me to actually put the test points on to show it to you. But I'm going to measure this without the flashlight before I power up to make sure I have something other than 0 or infinity. Okay, the next thing we're going to do is put this tube system back in. I've moved the carriage back to the right, and I'm going to take the crane portion of this and stick it down between the frame members. Get it into position here and just snap it in. That's about all there is to it. Get the blue portion here, snap it into place. The rest of it's just getting the tubes back into the channel. Now we do have to put this T8 screw back in to make sure that that thing stays solid. Okay, I've turned the machine around so I can make it easier for you to see how to get this back in. These pieces right here go on these tracks right here. Don't want to trap the cable back there. You push that in part way, and then I'm going to reconnect the ribbon cable on the blue connector and the air pressure tube goes back on the air pressure connector right here. Okay, push it forward so we can latch these. It should go right into the slots and latch fairly easily. And that's it. And then we're going to reattach the anchor here on the frame. Just like that. And it's good to go. I've powered it up. I've let it go through its head alignments and various startup calibrations. We need to do what's called the advanced calibration. The reason this is important is because we've made some changes in the x-axis. We changed the belt, we had the carriage out, we did all that stuff. So now we're going to match the x and the y-axis exactly. And the machine can't do that by itself, it needs some help. The way to get into this menu is to go to the main setup menu. We're going to choose Utilities, and in the Utilities menu, Calibrations, and in Calibrations we're going to choose Accuracy. We press that. We restore factory defaults, but that's not where we are anymore. We don't want to do that. So we're going to recalibrate, and we're going to create a pattern. Here's where we're going to use the polyethylene film that was in the kit. So I'm going to hit enter. This is going to go through a rather lengthy process where it is making some internal measurements, and eventually it will come back and ask for paper. I'll come back at that point. Okay, the machine has gone through its initial testing and calibration for the accuracy adjustment. Next thing we're going to do is load the paper. The display is asking for sheet, so we're going to give it a sheet. Line it up with the blue lines there, and we'll bring it down. And stuff's a little bit stiff. You may want to hold it up like this to help it load. I'm going to tell it that this is high gloss photo because that's the finish that's on it. It'll lay down the proper amount of ink as a result of that. Once the rollers pick this up, I can let go. Okay, it should handle everything just fine from there. Okay, the printer printed the calibration pattern. I've taken it out of the machine and draped it out here so you can see it. You'll notice along the right edge there are arrows. These arrows go into the machine next, or go in first, so that the printer can read the pattern in the other axis. We have to tell it what we want to do. So we're already in recalibrate, so now we're going to step this down to measure pattern. If for some reason you get out of this, the sequence is printer setup, utilities menu, calibrations, accuracy, recalibrate. First time you're going to create the pattern, second time we're going to measure the pattern. So I'm going to go ahead and load this in and let it read. Okay, the printer measured the pattern, made its calibrations, stored the information that it got, and from here you're ready to go back into production. My recommendation would be to do a simple production job just as a test, but other than that, that's all there is to it. I highly recommend you use the kit if you haven't done this before, and the video, and it's really not too bad. We've gotten a lot of people through this procedure, and we can get you through it too. Have a great day.